What is happening, people? Hey, here we go. Believe it or not, we're at the end of chapter 5, right? That's pretty exciting. Here we go, 5-6. I promised you we would graph these inequalities. Yes. Now we're going to, okay? Got some new words to introduce you to, though. First and foremost, we have this thing we call a boundary, or we might refer to it as a boundary line. All this is a line that just breaks our graph basically into two parts, okay? So it's going to be a line going through our graph, right? It's going to look like that, and it's going to break our graph into this part down here, and then it's going to break our graph into this part over here. Okay, that's all it is. The half plane, well, we have two halves make a whole, right? So on our graph, we will have our boundary line, and then each one of those areas, they're just going to call a half plane. Okay? We have open and closed half planes depending upon what kind of line my boundary is. Okay? Our boundary line, let me get rid of this. Our boundary line, guys, can be a dashed boundary line, or it can be a solid boundary line. You guessed it. What will change it is the inequalities. So if we're just a less than or a greater than, we will be a dashed. And if we're the less than or equal to or greater than or equal to, we are going to be a solid line. So you can think of it just like we've been doing with open dots, closed dots, right? If you're a solid line, we say that you're closed and you're included in the solution. If you are a dashed line, that would be an open half plane, and you are not part of our answer. Okay? Again, so you can write down all that stuff. If you need to pause this, do that. If not, we are going to bop right into slide number 1. Okay. It says graph this. You guys like that? That's funny. Come on. Desmos, possibly? Good news for you folks. I've got all this lined up for us right here. Okay? All right, here you go. Mr. Waters here, guys. Look, it's Sunday. Mr. Waters in here checking clocks. Look, it fell back, didn't it?
Yesterday.
It did. That's great. That's great. All right, carry on, Mr. Water.
You too.
Sweet. Okay, guys, so here's our graph of this one. Yes, Desmos will graph in standard form. Not a big deal there. Here we go. So here, let me make this go away. So guys, here's our two regions, right? So here's a half plane. Here's the other half plane. Why is this one shaded in? Well, this is our solution set or area. All of these, remember, we just graphed 2y minus 4x greater than 6. Think about that. That means every single ordered pair that we see in here, right? If you picked out an ordered pair, I'll go -6, -2. And we replace x and y with those numbers, do some multiplying and subtracting, we will get a number that is greater than 6, right? How many ordered pairs are in the shaded area here? There's a lot, right? So this is what we have to try to understand, guys, right? Graphing this isn't challenging. What is challenging and tough to wrap our brains around is the shaded area is my solution area. And every ordered pair that you see in there is an answer, right, to this inequality. Now, let's talk about the solid line versus dashed line. So, guys, if we go in here, can I zoom in? Who knows? Probably not. So, if we were to pick an ordered pair, right, this one right here, -1.5, 0. Can you get? Yeah, you guys can see that. It's right on our boundary line. If we were to put, so -1.5 is an x, 0 is a y, right? We put all that in there. It will not give us a true statement, right? It's just not going to. And that's why it's not an answer or a solution in this one. So any ordered pair that falls on that dashed line, not a solution, okay? Now, if it was a filled-in line, then of course it is part of our solutions. Okay. All right, so let's hop back over here real quick. So graph this, we did. We talked about the graph and kind of what it needs to look like. Sometimes, guys, the book might just give us this and say, hey, figure it out. Again, we could figure this out if we wanted to. You guys want me to do this one without Desmos? Of course you do. Y less than 3x plus 2. So, guys, this one's going to have a y-intercept of 2. So, okay, it could be that one. Could be that one. Could be all of these. But I can tell you right now it's less than, so that means it's going to be a dashed line. So that means these two are out. Okay? And we're less than this expression here. So I think if we figured it out, yeah, it's going to be this one right here. Okay? Again, we could double check that on Desmos. Probably not a bad idea. I mean, let's be honest. I'm not perfect. I make mistakes all the time. Go away. Bam. There we go. All right. So again, y-intercept is 2. We're shaded below the origin on this one. All good things to know. Okay. So we pick A. Graph this one, x plus 4y greater than or equal to 2. Again, think about what this is going to look like, right? Greater than or equal to. What kind of boundary line are we going to get? That's right. It's going to be a solid boundary line on this one, okay? Turn off, turn on. Here it is right here. So this is we call this the closed half plane, right? Because it's closed because we are using that boundary line as part of our solution area. All right, again, nothing down here. You can make any of these ordered pairs. They will not give us a true statement in this inequality. When I take the x ordered pair number and I add that to 4 times y, right, we will always get greater than 2 for these. None of these will give us true statements. Okay? So again, that's what these look like on a graph. We're not going to spend all day and forever on trying to hand graph these. As you guys know, we use Desmos for graphing. All right. What we are going to do is figure out fun stuff like this. Okay. Again, x plus 2y greater than 6. Looks like this one here. Again, our y-intercept is 3. We're shaded above the line. This one, again, A. Why can't it be C? Those have the same shaded area, right? You're right, they do. However, this is open. This one's closed. Now we have to write an inequality to represent this one. Okay, so these are always the goofy ones, guys. So vertical lines, horizontal lines always give everybody fits. So remember, if I'm going to write, whether it's an equation or an inequality, you just ask yourself the same 2 questions. A, what axis does it go through? 2, what number does it go through? That's it. There's your equation. Nothing more. So I'll ask you, what axis does this go through? X-axis. Very good. What number does this go through? 2. Now, so this is the shaded area, right? So all of this stuff here, these are all answers in it. So think about these numbers, x values, compared to 2. Bigger, smaller, bigger, smaller. Smaller. Solid line here tells me I want that inequality, right? Less than or equal to 2. Again, if you're not sure that this is it, I bet we could graph it. You know what I mean? On Desmos. There you go. We did do this right. Nice job, people. Okay. Use a graph to solve this one. So again, you can solve this equation, right? This is add 3 to both sides. 5x less than or equal to 20. So we get x's that are, less than, greater than or equal to 4. No. What are we getting greater than or equal to from? Who is messing this up? Greater than, there you go. So we're going through the x-axis on the number 4, and we're picking all the numbers bigger than it. All right? Yeah, right here. Okay? All right, and then really, guys, the only challenging part to this one are when we get stuff like this, right? And now we have to write it, but then I think the harder part is to make sense of it. So we're going to slow down. Hopefully I haven't gone too far. We're 10 minutes in. Oh, this is easy. Okay. All right, so our buddy here, Ranjan, writes and edits short articles for a newspaper. Takes him an hour to write an article, about a half an hour to edit it. So if he has an hour and a half, how much can he do? Well, he could write one and edit one. He could edit three, couldn't he? Because if each one takes a half an hour, half hour, half hour, half hour, hour and a half. Okay. If he works up to, again, there's your inequality, 8 hours a day, how many articles can he write and edit? Okay. So X is going to be writing, right? I'm going to say Y is editing. So there's some amount of writing and editing, right? It doesn't really say like he has to write a specific amount. It just says he has a specific amount of time that he works, right? And he does these two things. Well, this takes him 1 hour. This takes him a half an hour. There is some combination of writing and editing, right, that will take up 8 hours a day for him. So that's how we write this one. Again, if you wanted to write it as x plus 0.5y less than or equal to 8, that's fine too. Okay? But then, all right, well, let's graph this and let's kind of think about what it wants to know. It says, how many articles can he write and edit in one day? Is there only one answer? Is there only one answer to this problem? No, there's lots of different answers, right? So how many articles can he write and edit in one day? Okay, so we just have to remember X is writing and Y is editing. Maybe I'll leave those up as we flip over here. Okay, so I've graphed this one right here, guys. Okay, so great. I knew I had my... Whoa. All right, let's zoom in a smidge. Okay, so guys, I know we see all the quadrants on here. I am really only concerned with quadrant 1, right? I'm really just focused in. Of course, I would pick a color that just blends right in with my graph. I'm really only focused, right, on this triangular piece right here. Because, again, I only have 8 hours in my day. I cannot write or edit it negative amounts of articles for this newspaper. So negatives make 0 sense, okay, in this one. Okay. Again, the question was, how many can I write and edit in one day? Well, it all depends on what I'm choosing to do. Remember, each one of these ordered pairs in here is a combination or a solution to how much I can write and edit in one day. If you don't believe me, right, let's look at some of these, right? Yeah, so like, look, these are all combinations. Bam, 0, 16, and 8 and 0. So if I, remember, X is writing. Can you see? Well, you can barely see that. So X is writing, Y is editing. So if I write 0 and edit 16, that works, right? That eats up 8 hours. Or I could write 8 and edit 0. Again, that is also a combination, right? Now, you got to be careful, right? Is this one right here, 6.1 and I was on, and 3.8. Can I write 6.1 articles and edit 3.8 articles? No, we can probably only do whole numbers in terms of this, right? So like 5 and 6, I think, is a good ordered pair. So I could write 5, edit 6, all right? But here's the deal. I can't write any more than 8 articles in a day, nor can I edit any more than 16 articles in a day, right? And there's some other combinations as well, you know what I mean, of answers that will be in there. Again, all of the answers, guys, on the line eat up 8 hours of my day, okay? If we look at all the solutions that are inside of that line, right, these are all combinations, right, that would eat up exactly 8 hours, right? If I wrote 2 articles and edited 2 articles, well, that's only going to take 3 hours. You know what I mean? That's not going to take me forever, right? And you would see that Somewhere, I think probably right about here is that point. Okay? Did we answer everything we needed to? I think we did. All right. Yeah, so there we go. So how many articles can he write and edit it? So we said he could write at most 8, edit at most 16, and then there's some other combinations as well. All right, last one. We've made it. You offer to go to the local deli and pick up sandwiches for lunch. Nice of you. You can have $30 to spend. Chicken sandwiches are $3. Tuna sandwiches are $1.50. How many sandwiches can you purchase? Well, first off, guys, think back to, can I buy a half a tuna sandwich and 3.5 chicken sandwiches? No, right? So we can only buy whole amounts of sandwiches. All right. So once again, guys, I'm going to say X is chicken sandwiches, Y is tuna sandwiches. Again, 3X plus 1.5Y equals however much money I have, $30. Well, again, sorry, not equals, less than or equal to. Okay, less than or equal to. Let's take a look at this one on the graph. Go away. Let's boom, boom. There we go. All right. So again, any of these combinations inside this triangle here work, guys. If we pick, right, there we go, 10, 0, 0, 20. So if I buy 0 chicken sandwiches, I can buy 20 tuna sandwiches. If I buy 10 chicken sandwiches, can't buy any tuna sandwiches, all right? And then all of these other, right, combinations work. Like 8 and 4, right? That works. What's this one? 6 and 8. Maybe, where'd it go? Yeah, 6 and 8, right? 4 and 12, 2 and 16, right? These all are combinations of sandwiches, chicken and or tuna, that we could buy and still spend exactly our $30, okay? If we're not going to spend $30, that's where we're going to get all of these, right? Like, hey, this point right here, right? This point right here and this point right here, right? These are all going to give us good numbers, but they're not going to give us amounts that work up to that $30, okay? So again, you can fill that in for our last one. Where? Oh, no, it's all gone. Make it come back. There it is. Okay. So how many sandwiches could you purchase for $30? So again, we went back to the fact that, hey, you could buy 20 of these, or you can buy 10 chicken ones, right? Or other combinations that are in there as well. Okay. Guys, that's all I got for you today. So I hope it was great. Hope you enjoyed Chapter 5, because we're at the end of it. All about absolute values. I'm sure they are one of your favorite things to do. So if you have questions, let me know. If not, we'll get into our bookwork and our quizzes, and you guys will be great. All right? Take care.